We're going to look at raising complex numbers to different powers and taking roots of complex numbers. And we have two ways to do that. Either Tamar's theorem for raising it to a power, or there's a formula for taking roots of complex numbers. But in either case, they both have to be in trig form. So if they're not in trig form, that has to be your first step to get them into trig form. So Tamar's theorem says if you have a complex number you're raising to a power and it's in trig form, you apply that power to r, and then you just multiply your angle by that number. Not raise it to that power, but just multiply it by that. So we're going to evaluate this. Now, I suppose one way you could do it is to take this and multiply it out 5 times, because that means fifth power. But being so many negatives, i's, and roots, there's a good chance by the time you got done foiling it out 5 times that you would have made a small mistake somewhere. So we're going to use Tamar's theorem to help us out. So first of all, we're going to put this into trig form. So we're going to draw ourselves a triangle. We're going to go 2 root 3 to the left and 2 down. Remember, in putting it in the trig form, you don't include the I when you go down. It just tells you how far to go up and down. So you could do the Pythagorean Theorem, this whole side squared plus this whole side squared equals r squared. And so we get 4. And then you could find your angle. Well, you were given opposite and adjacent, so you could do tangent. And so you get tangent is equal to this, but that simplifies down. The negative 2's drop, and you'd have 1 over root 3, which is a root 3 over 3. And you're supposed to know when is tangent equal to root 3 over 3. And it happens to be in the third quadrant. So you would know that your angle would be 7 pi over 6. So if we write this in trig form, we'll go and put it into trig form. Our r is our 4. Our angle is 7 pi over 6. And whatever's after the cosine has to match whatever's after the sine. Still all raised to the 5th power. So our formula up here says we got to apply that power to our r. And then we got to take our angle and multiply it by that power. So it's just your angle multiplied by 5. And whatever's after your cosine matches whatever's after your sine. So if we work this out, we get 1,024. Multiply our 5 times our angle, we get 35 pi over 6. Now 35 pi over 6 is more than once around. So we could subtract a full revolution or keep subtracting multiple full revolutions till we get something between 0 and 2 pi. Or if we were dealing with degrees, we could keep subtracting 360 till we got between 0 and 360. So if you do that, we end up getting 11 pi over 6, which is one that we're supposed to have memorized from our unit circle. So we can go this, cosine of our angle, plus I sine of our angle. Then we could distribute through. This would be our answer in the rectangular form, where this would be our answer in trig form. But since we started out with the rectangular form, we want to leave our answer in rectangular form. So now, if you're dealing with the root of a complex number that was in trig form, you would want to use this formula here. The nth root of r, then you go cosine your angle plus 360 degrees k over n, and then whatever's after your cosine has to match whatever's after your sine. Now, if you didn't want to work with degrees and wanted to work with radians, it's the same formula. You just replace your 360 degrees with a 2 pi. Then k always starts out at 0 and goes up to one number less than n. So you have two formulas here, one dealing with roots, one dealing with raising it to a power. So make sure you're being careful on which formula you're using. If you're raising it to a power like this one here, use your formula that has a power in it. If you're dealing with taking a root of a complex number, use the formula that has a root in it. But in either case, both of these formulas you need to have in trig form. So let's go ahead and do the fourth root of 16. There's 4 roots of 16. Now, it's really in a plus bi form. It's really 16 plus 0I. We want our answers in rectangular form, but we also want our answers in trig form. So we're going to use our roots of complex numbers formula. So the first thing I would do is graph this. So we're going to go 16 left and right. So we'll go 16 to the right and we'll go up 0. Then I would write down what your angle is, what r is, what n is, and what k is. Well, r is just your distance from the origin, which is 16. Your angle, you're going straight to the right, so that would be 0. N is the root you're taking, and we're taking our 4th root. And k starts out at 0, always goes to 1 less than the number of what n was. So it's going to go up to 3. So now, come along, take r, theta, and n, and plug them into your formula. So we're going to go the nth root, which is the 4th root, of r is 16. Plug in what your angle is, which was 0, and then divide it by what n is. N, once again, was 4. Now, at this point, I would just kind of simplify what I have. The 4th root of 16, you should know, is 2. Adding 0 doesn't change it, so we get 2 pi k over 4, which is really just pi k over 2. And then once again, whatever's after your cosine has to match whatever's after your sine. Once I plug stuff in and simplified, now I'd start plugging in the different values of k. So I would go ahead and plug in k being 0 into here. Well, if k is 0, I still have a 2 in front. I get the cosine of 0 plus I sine of 0. That's my answer in trig form. Then I know the cosine and sine of 0, so I could write those down. I can distribute through, and then I get my answer in a plus bi form. So now all we have to do is go back and plug in k being 1. If k is 1, I get pi over 2 for my angle. That's my answer in trig form. I could evaluate, work out what the cosine of pi over 2 and the sine of pi over 2 are, distribute through, and I get my answer in a plus bi form. Then I come back and I plug in 2. Plug in 2 to my formula, and I get the cosine of pi and the sine of pi. My answer in trig form. Evaluate the sine and cosine of pi, distribute through, and I get my answer. Now I'll go ahead and plug in 3. And I get my answer in trig form, plug in what the sine and cosine of 3 pi over 2 are, distribute through, and I get my answer. Now, suppose you did not stop at k being 3 and went on to k being 4. Well, if you did that, you would get a 2. If you plugged in 4 here, you get a 2 pi. So you get cosine of 2 pi plus I sine of 2 pi. Well, you should realize that cosine and sine of 2 pi is identical to this. So if you forget to stop, you really just start duplicating your answers. So just be aware of that. Now, we have our 4 answers in trig form, highlighted in blue, our 4 answers in rectangular form, highlighted in green. So here we want to find our 3 third roots of 4 root 3 minus 4i. Once again, we want it in a plus bi form and in trig form. So first of all, I want to go ahead and graph this. So I'm going to go 4 root 3 to the right, and I'll go down 4. So now I can do Pythagorean Theorem to be able to get my hypotenuse, which is r, and in this case I would get 8. N is the root you're taking, which we know is 3, so it's the third root. K would be 0, 1, 2, and Then we go ahead and find out what our angle is. We have our opposite and we have our adjacent, so I'd use tangent, simplify my fraction, and I could then figure out when is tangent equal to that fraction. And in this case, I get 330 degrees, which is in the fourth quadrant. Because my angle is in the fourth, or number was in the fourth quadrant, I want to look for my answer in the fourth quadrant. There is another spot where my tangent would have the same angle, but that's in the wrong quadrant. So now I come along and plug in what n is, the nth root of r, so it'd be the third root of r, which is 8. Plug in my angle, 330 degrees, put it over n, which is 3. Then I would do some simplifying. The third root of 8, you know, is 2. Cosine, well, I could divide both of these by 3, and I get 110 degrees plus 3, or 120 degrees k. And then once again, whatever's after your cosine has to match whatever's after your sine. Now that it's simplified like this, I would now start plugging in the values of k. Plug in k being 0, I get an angle of 110. Plug in k being 1, it'd be 120 plus 110, or 230. Then I'd plug in, oh, that's a funny looking 2 there. Plug in 2, and I would then get 350. Now, because cosine of 110 or the 230 or the 350 are not ones you're supposed to have memorized from your unit circle, we're going to just type in each one of these lines all at once into our calculator. But make sure your calculator is in the A plus BI mode. So hit mode, make sure the A plus BI is highlighted. So then go to, open parenthesis, cosine 110, close your parenthesis, plus I sine 110, close your parenthesis, and you should get this. Make sure you're also in the degree mode because you're dealing with degrees. You type in the next one, we would get this, and then type in our third one, we would get this. So if you're not dealing with the angles you're supposed to have memorized, it's okay to give me approximations. But if the angles are one you're supposed to have memorized, work out exact answers. So one last problem here. We need to solve this for x. Well, to solve it for x, you'd want to get x by itself. So you'd have to subtract your 9i from both sides. And then you'd have to take the square root. Now, a lot of people, if they just do this, will stop. I would encourage you not to write this. I would encourage you to write the second root of negative 9i. Because if you do that, you'll realize, oh, it's just like the last problem. So then all you'd have to do is graph this, find n, r, k, theta, and plug it into your root formula. So if we graph this, we're left and right 0, and we're down 9. We're dealing with the second root. R is your distance away, which is positive 9, because you're just 9 down. K would be 0, 1. Your angle to go from here all the way down to the bottom is either 3 pi over 2 if you're dealing with radians, or 270 degrees if you're dealing with degrees. So then we plug stuff into our formula. The second root, which is square root of n, which is 9. So we know that's going to be a 3 in front. Plug in our angle of 270 degrees. Divide it by n, which we know is 2. So now we could divide each one of these by 2, and we get 135 degrees plus 180 degrees k. And then whatever's after your cosine has to match whatever's after your sine. Now that it's simplified, I would go ahead and start plugging in values of k. If k is 0, we get an angle of 135 degrees. If k is 1, you'd have 180 plus 135, which is 315 degrees. In each case, 135 or 315 are angles you're supposed to have memorized. So you can go 3 cosine of 135 plus I sine of 135. And then we can go 3 cosine of 315 degrees plus I sine of 315 degrees. Distribute through, and we get our two answers. Now, keep in mind, we have our one answer, and the other answer is the exact opposite. So, as a side note, if I gave you x squared is equal to 16, you would say x would be equal to plus or minus 4. We say positive and negative typically, but it's really one answer, and the negative means it's opposite. So you have one answer and its opposite, and that's exactly what we have here. We have our one answer, and we have the exact opposite of that. Now, what you could do to double check your work is to take your answer right here, put it in your calculator, and square it. If you type this in and square it, because we were dealing with the square root, you should get the original problem of that negative 9i. So that's how you can go ahead and double check your answer to see if you were correct.